Hey you guys, let's talk about numbers real quick. Right here I have a number line, and of course I have positive values going to the right of zero, negative values on the left of zero, and zero is neither negative or positive; it's neutral, right? So we can actually kind of classify these things or compartmentalize these things into different categories. I'm going to start with anything above zero and positive. So if I take numbers, all these numbers, right, we can call those natural or counting numbers. Cool, right? And it goes on to infinity. The reason why they're called natural or counting numbers, right, is because we can count them. They occur naturally in life. I can give you $1. I can give you $2. Give you $1,000,000. I can step 2 feet. I can go a distance of 1 foot. However, I can't give you $0. I can't achieve zero distance. I cannot go negative 2 feet. Does that make sense? So these occur naturally, and we can even enlarge this or expand this, right, and include zero. And this will be whole numbers. So you get the whole number set when you include zero. So, or the whole number set includes natural and counting numbers. And then we can further expand this to include negatives, right? And those are integers. So essentially, an integer is a negative number, a positive number, and zero. A whole number is anything positive and zero. And then a natural or counting number is essentially anything positive, right? Yeah, that's essentially what it is. So we have those classifications, and then we can take these numbers and either call them prime or composite. So what isn't prime is composite, and vice versa. Composite, right? Let me give you an example of a prime number. So prime, let's say 3. The reason why it's prime is because it can be, and this is the underlying property of prime, is that 3 can be divided by itself and 1 only. So its only factors are 1 and 3. Same thing with 5, right? The number 5 can only be divided by 1 and 5. There are no other 2 factors or multiples that can go into 5. So whatever isn't prime is composite. So composite, let's take 4, right? 2 times 2, why not? 1 times 4. So if it happens that 4 was only divided by or divisible by 1 in itself, like right here, then it would be prime, but we have this going on. Same thing with 9. 9 is 3 times 3 and 1 times 3. So these are composite numbers, and these are prime. So we have integers, and within the integer number set are whole numbers, and within the whole number set are natural counting numbers, right? And then if you were to take any integer, you can either classify it as prime or composite. Okay, now let me go forwards a little bit. There were 4 fundamental, so 4, I guess say functions, fundamental overlying functions, right? That we usually perform on numbers. It's division, subtraction, right? Addition, and multiplication. Right? The reason why I roll them side by side is because these kind of go hand in hand, and subtraction and addition go hand in hand. Usually they're reverse processes. If I multiply, say, 5 times 5 is to 25, right? Well, to get me back to 5, I have to divide by 5 equals to 5, right? Or same thing, vice versa with subtraction addition. 5 plus 5 equals to 10, right? Or if I subtract 5 from 10, I get 5. So they kind of work hand in hand, and you'll see in later stages of math how that concept right there applies to multivariables, etc. So to understand that now is essential. Let me erase this real quick. So we have division, and we have subtraction, and we have multiplication, we have addition, right? I'm going to take division real quick, right? Because if we take two integers, remember I said integers apply to any of these, negative, positive, right, or 0, say 2 and 3, and divide them, right? Then we have a rational number now. So before we had an integer, we had a whole number, and we had natural counting numbers, but they were complete full numbers. They were not decimal or fractional, right? By taking two integers and then playing between them both and dividing between them both, we get rational numbers. And we know it's rational because it's fractional. It's written as a fraction. Fractions. Right? Anytime you see a fraction, it's rational. Irrational, non-fractions. Cannot be written as fractions. Right? I'm going to carry on with rational. Irrational we'll talk about later. Rational, there are two properties. They can either terminate or repeat. And what do I mean by that, right? Let me take this space right here, right? So follow along with me. I'm a little disorganized. It's been a long morning. I'm going to get better at this, I promise. So if I take 2/3, right? I can write it in decimal form simply by dividing, or executing that process right there. 3 goes into 2, it does not, right? At a trailing 0 point, right? So 3 goes into 20, 6, 12, 18, yeah, so 6, 18, you get 2, and then bring down another, so, and then 6 times 3 is 18, 2, bring down another 0, you get 6. So we can see that this is going to continue on, and it's going to continue repeating. We see a pattern going on. So, and put a bar line. As I said, one of the properties of rational numbers is the fact that it repeats, and we see that here. What about a non-repeating or terminating rational number? Right? So if we have a terminating number, so 2/3 in its decimal form was 0.666 blah blah blah, and it goes on. That's repeating. What about 1/2? Right? 1/2, 2 goes into 1, it does not. Right? That's 10, 0. So a remainder of 0. And this means that we can no longer carry on with this, and it ends there. So it terminates. So 1/2 in its decimal form is 0.5, and it terminates. The other property that we mentioned is terminating. So I have 1 minute left. So again, you have integers, whole numbers, natural counting, and rational. And numbers themselves can be classified as either prime or composites. I hope this helped. I'm just going to stop here before it cuts me off, and then continue onwards with another video. Later, you guys.